Okay, let's talk about our third and final type of transformation this term called a rotation. And sometimes you'll hear rotations referred to as turns. And that's exactly what happens in a rotation is we're taking some sort of object and we're turning it this time. A rotation is always around a specific point, and we can turn the object by varying amounts or different number of degrees, right? And even different directions, whether it be clockwise or counterclockwise, to make up different types of rotations. And the first rotation we're going to look at today is a 90-degree clockwise rotation. Our pre-image, this triangle ABC, is entirely ensconced in quadrant 2, and to show you this specific type of rotation, we're actually going to rotate the entire quadrant. The reason I'm doing that is because all the rotations you're going to see today are rotations about the origin. The origin here at point 0, 0 is where our objects are going to be pinned in place, and everything else is going to turn around that point. Now a 90-degree rotation, let me bring up the protractor to show you how much a 90-degree rotation is going to be. Means that I'm going to take this line down here at the x-axis, 0 degrees on my protractor on this side, and I'm going to turn that line so that it ends up at the top of my protractor at 90 degrees. That's going to be a 90-degree clockwise rotation. So let's see if we can get this to work. Sometimes we have some technical difficulties, but we're going to take that whole quadrant, which contains our shape, and we're going to rotate that about the origin till we're up here at 90 degrees. And now I've rotated our object about the origin again, 90 degrees in a clockwise motion. Let's close our protractor and take a look at what that did to the shape. First of all, let's compare, or let's take the time to compare some coordinates, right? Notice that point A was in the upper right-hand corner when I rotated that. Now it's in the lower right. Point C was in the lower left corner when I rotated up. Now it's up at the top. You have to be a little careful with rotations so that you're matching up your pre-image and your image in the correct order. Then we can take a look at the coordinates. If I compare point A to point A prime, I went from -3/8 to +8, +3. Very, very similar, but there are some minor changes there. Point -4/3 went to +3/4, and -9/3 went to 3/9. See if you can tell what changes took place from pre-image to image. I'll give you just a second. Can you see that the X and Y coordinates actually kind of switched places, right? What was X and Y is now YX, but there's one other change that took place in that the X value actually changed sign, right? Went from negative to positive. So in our arrow notation, we're going to kind of bring that to light. R is going to stand for rotation this time, and we're going to take every value xy and we're going to switch the order so that our new point has our old y value first and our old x value, including a sign change, second. And again, that's what happened with every single point from pre-image to image in our 90-degree clockwise rotation. And it won't matter what quadrant you start in and where you end up. Anytime you have a 90-degree clockwise rotation, that same transformation is going to take place. when we abbreviate that notation, we state what's happening in the subscript to our original point. Sometimes you'll see this as the subscript as 90° clockwise. You can do it either way. Now let's look at a 180° clockwise rotation. Again, we're going to use that same quadrant since our entire triangle is in quadrant 2. And let's take a look at what a 180° rotation would look like. If I'm going to go clockwise, that means that this line, again, down here on the x-axis, 0 degrees on my protractor over here, is going to have to rotate all the way around to the opposite side of my graph. That's going to be a 180° rotation. So let's see if we can make that happen. Now we're going to rotate our shape all the way around. Remember that one line had to come all the way to the other side of the graph. And there's our 180° clockwise rotation. Now if I had gone counterclockwise, a 180° rotation is actually the same either way, clockwise or counterclockwise. You're still going to the opposite side of the graph. But now let's look at the coordinates, right? Let's get the protractor out of the way. Point A that was up here at the top, as I rotated to the other half of the graph, is now on the bottom of my new triangle, of my new image. Point C that was on the outer side when I rotated around is now on the far right side of my image. So when I write my coordinates in, or my prime points, I need to be really careful when I'm rotating. Now let's take a look at the coordinates. Our point A was at -3, 8, is now at 3, -8. -4, 3 is now at 4, -3. And -9, 3 is at 9, -3. So now what transformation took place? Did the x and y values change order this time? Absolutely not. But notice that -3 went to +3 and +8 went to -8. So we need to, in our arrow notation, kind of indicate what is happening with our new points. So we're going to say R for rotation changes all our values x, y into the opposite of x and the opposite of y. Remember, negative doesn't actually mean negative. It means change the sign or take the opposite sign of what's already there. Our abbreviated notation, we can say R sub -x, -y, or we can say R sub 180 clockwise. Both notations are going to indicate the same amount of rotation. Last but not least, let's look at a 90° counterclockwise rotation. And we're going to do the same thing. We're going to take all of our points up here, and let's see if we can rotate that the other direction. This time we're rotating counterclockwise. Looks like I'm going to have some technical difficulties on this one, so I'm just going to show you what it looks like after a rotation. Remember, now our top line is going to go backwards 90 degrees. And the bottom line will now go 90 degrees down to the bottom of our graph. So now when we look at our pre-image and image points, let's look at the coordinates and see what changes took place this time. This time, point A went from -3, 8 to -8, -3. -4, 3 to -3, -4, and so on. So take just a second and see if you can define the changes. This time with our rotation, they switched order again. 3, 8 became 8, 3. The x value did not change sign, but the y value did. So now all points x, y are going to become the y value first with a sign change and the x value second in our image points. And again, that's going to happen with any 90-degree counterclockwise rotation, regardless of where you start from. So in your notes, it's a really good idea to have these 3 different arrow notations written down for the 3 different types or most common types of rotations. There's lots of others you can rotate any number of degrees, but these are the 3 most common. Now let's take a look at what types of problems you'll run into most likely with rotation practice. Here we have a rotation. Can you tell what type of rotation has taken place? Make sure to pay attention which one's your pre-image and which one's your image. This, since it went from one quadrant to the very next, would be a 90-degree rotation, and obviously we went clockwise. So this is a 90-degree clockwise rotation. This one, looking at the pre-image and the image, went 90-degree counterclockwise. And when you move or rotate 2 quadrants over, that's got to be a 180-degree rotation. Whether you go clockwise or counterclockwise, it's going to be the same. Sometimes you'll be asked to identify the type of rotation based on coordinates only, and that's where your arrow notation is going to come into play and be really helpful. What type of rotation was it that let the order stay the same and change sign on both values? That was our 180-degree rotation, whether it be clockwise or counterclockwise. Both would be correct. How about point P that went from 8,2 to 2, -8? They switched order and the original x value ended up changing sign. Looking back at our notes, which rotation was that? Isn't that our 90-degree clockwise rotation? And last but not least, how about point Q that was originally at -1, -5 and is now at 5, -1? Again, switched order, and it was the original y value that switched sign. Take a look at our notes one last time, and we can see that that's a 90-degree counterclockwise rotation. To wrap up, some things to remember. Be sure to be really careful to watch for which object is your pre-image and which is the image. I would recommend picking a test point to check which arrow notation is most appropriate for your graph. And don't forget, the arrow notation will be the same for each type of rotation regardless of where the original object began. We're going to wrap things up for today. I hope the rest of your day goes wonderfully well, and I'll see you next time.